Hi everyone, I am Ramya Gunuru, pursuing second computers at Specialist Degree College, Paikropeta. Today I am going to discuss about Carnot reversible heat engine. What is Carnot reversible heat engine? Carnot heat engine is a device which is to convert heat energy into mechanical work. The basic model for this heat engine was designed by a French engineer Carnot in the year of 1824. It is an ideal heat engine which is working under reversible but practically not easy to construct. It consists of four parts. In that, the first one is working substance. It is an ideal gas enclosed in a cylinder with non-conducting piston, and the cylinder walls are made up of insulating material, but the bottom part is conducting material. By using this, we can observe expansion and compression of the gas. See here, the piston and the walls are made up of insulating material and the bottom part is made up of conducting material. And the second one is source. It is a hot body to be maintained at a very high temperature T1 degrees K. The walls and bottom part of the source is made up of insulating material and the upper part is made up of conducting material. See here. Source having a capacity that how much amount of heat energy is taken from it. It doesn't alter its temperature. It is useful for isothermal expansion of the gas. And the third one is sink. It is a cold body of low thermal capacity to be maintained at low temperature T2 degrees Kelvin. The walls and bottom part of source is made up of insulating material and the upper part is made up of conducting material. It is the diagram of sink. Sink having a capacity that how much amount of heat energy is given to it. It doesn't change its temperature. It is useful for isothermal compression of the gas. And the fourth one is insulating stand. It is a stand which is made up of insulating material and it is useful for adiabatic changes of ideal gas. Now we can explain the working of Carnot heat engine by using a graphical representation, that is Carnot cycle. And it is the diagram of insulating stand. What is Carnot cycle? The working of ideal gas can be explained by the following graph which is drawn between volume along x-axis and pressure along y-axis. It is consisting of four different curves. The first one is isothermal expansion AB curve. Second is adiabatic expansion BC curve. Third is isothermal compression CD curve. And the fourth one is adiabatic compression DA curve. And it is the diagram of PV. PV is nothing but pressure and volume. And here there are four coordinates. And the coordinates of A are P1 V1 T1. For B, P2 V2 T1. For C, P3 V3 T2. For D, P4 V4 T1. The first one is isothermal expansion AB curve. Consider 1 mole of ideal gas enclosed in a cylinder under isothermal expansion of the gas with the initial coordinates P1 V1 T1 at A and final coordinates P2 V2 T1 at B. When the cylinder is placed on the source and expands isothermally by absorbing Q1 amount of heat energy, the work done can be calculated as follows.
Now we are going to discuss about isothermal expansion AB curve. From PV diagram, A equals to P1 V1 T1 and B is P2 V2 and T1. In isothermal expansion, T1 is constant, which means temperature is constant. Then W1 equals to Q1 equals to integral limits from V1 to V2. Because in isothermal expansion, temperature constant and volume varies. dW. The device W1 equals to Q1 equals to integral V1 to V2 P into D. Equation number 1. And we know that from ideal gas PV equals to MRP. For nmoles, PV equals to RP. Then P equals to RT by V. Here temperature is T1. So we have to write T1. This is equation number 2. Now substitute this equation number 2 in equation number 1. Then W1 equals to Q1 equals to integral V1 to V2. P means RT1 by V. RT1 by V into V2. Here R is universal constant and T is temperature is constant. So RT1 integral V1 to V2 1 by V V1. Integral 1 by V V equals to log V. That equals to RT1 integral 1 by V dV means log V. From limits V2 to V1. That equals to RT1 log V2 minus log V1. That equals to RT1 log V2 by V1. This W1 equals to Q1 equals to. Let is considered as equation number 8.
And the second one is adiabatic expansion BC curve. Here the gas cylinder is detached from the source and placed on insulating stand. Here the initial coordinates are P2 V2 T1 at B when the gas expands adiabatically. Then the final coordinates of the gas are P3 V3 T2 at C. The work done W2 can be calculated as follows.
And the second one is adiabatic expansion BC curve. Here the B coordinates are P2 V2 T1 and C coordinates are P3 V3 P2 from PV diagram. Then W2 equals to Q2 equals to integral V2 V3 limits VW. That equals to integral P2 V3 P into dV. That's the equation number 1. Then we know that PV power gamma equals to constant. Let us consider constant K. Then P equals to K by V power gamma. It's equation 2. Now we have to substitute this P value in equation number 1. Then substitute 2 in 1. W equals to Q2 equals to integral V2 to V3. In P we have to substitute K by V power gamma into dV. And next K is constant. We had already known. Then K integral V2 to V3. Remaining part 1 by V power gamma into dV. And we know that integral x power n dx equals to x power n plus 1 by n plus 1. Like that K into V power minus gamma plus 1 by minus gamma plus 1 from limits V3 to V2. And K by 1 minus gamma into, we have to substitute this V3 and V2 in this. V3 minus power gamma plus 1 minus V2 power minus gamma plus 1. Then multiply this K to this 1 by 1 minus gamma into K into V3 power minus gamma plus 1 minus K into V2 minus gamma plus 1. We know that from initial coordinates P2 V2 T1 we had already discussed. Then according to this we write here P2 V2 power gamma equals to constant. And final coordinates are P3 P3 T2. Then from this P3 V3 power gamma equals to K. That equals to 1 by 1 minus gamma into P3 V3 power gamma. Here there is K. For this we have to write P3 V3 power gamma. And here P2 V2 power gamma in K place. That equals to 1 by 1 minus gamma into P3 V3 power gamma into V3 power minus gamma plus 1 minus P2 V2 power gamma into V2 power minus gamma plus 1. Then that equals to 1 by 1 minus gamma into, here bases are equal, then power should be added. Then P3 into V3 power gamma minus gamma plus 1 like this. Then plus gamma minus gamma cancel. And next that equals to 1 by 1 minus gamma into here P3 V3 power 1 minus P2 V2 power 1 is nothing but P3 V3 minus P2 V2. For ideal gas, P2 V2 equals to RT1, P3 V3 equals to RT2. Let's substitute these values in this. Then W2 equals to Q2 equals to 1 by 1 minus gamma into in P3 V3 we have to write RT2 minus in P2 V2 we have to write RT1. Here take a constant outside R, then W2 equals to Q2 equals to R by 1 minus gamma into T2 minus T1. Consider this equation as given.
And third one is isothermal compression CD curve. In this process, the cylinder is separated from insulating stand and it is placed on sink. Here, the initial coordinates of the gas are P3 V3 T2 at C. Then the gas is compressed very slowly and reaches to final coordinates P4 V4 T2 at D isothermally. The released heat energy Q2 is passed to the sink.
Compression CD curve. And from PV diagram, C coordinates are P3 V3 T2 and D coordinates are P4 V4 T2. Then W3 equals to minus Q2. Here Q2 means the amount of heat energy is rejected from the heat engine. That equals to minus RT2 log base V3 by V4. And it is similar to the isothermal expansion. It is considered as equation number C.
And fourth one is adiabatic compression DA curve. It is the final stage of the process where the gas cylinder is detached from the sink and placed on insulating stand. With initial coordinates P4 V4 T2 at D, then the gas compressed very slowly, and final coordinates P1 V1 T1 at A.
Is adiabatic compression DA curve. From PV diagram, D coordinates are P4 P4 T2 and A coordinates are P1 V1 T1. And it is similar to adiabatic expansion when W4 equals to R by 1 minus gamma into T1 minus T2. It is considered as D equation. Total work done of Carnot heat engine. Then total work done is W equals to W1 plus W2 plus W3 plus W4. Then we had already derived that W equals to RT1 log base V2 by V1 and W2 equals to R by 1 minus gamma into T2 minus T1 and W3 equals to minus RT2 log base V3 by V4 and W4 equals to R by 1 minus gamma into T1 minus T2. That equals to RT1 log base V2 by V1 minus RT2 log base V3 by V4. Then here these two are same, then we are taking as common plus R by 1 minus gamma into T2 minus T1 plus T1 minus T2. Here plus T2 minus T2 cancel and plus T1 minus T1 cancel. Then W equals to RT1 log base V2 by V1 minus RT2 log base V3 by V4. Then we know that it is Q1 and it is Q2. That implies it is a work done of W1 and it is a work done of W3. That implies W equals to W1 plus W3.
Efficiency of Carnot heat engine. In the working of heat engine, Q1 is the amount of heat energy absorbed from the source in isothermal expansion at a temperature of T1 degrees Kelvin, and Q2 is the amount of heat energy rejected to the sink in isothermal compression at a temperature of T2 degrees Kelvin. Eta equals to output by input, that equals to total work done by heat energy absorbed, that equals to Q1 minus Q2 by Q1. Eta equals to 1 minus Q2 by Q1. Now we can express efficiency of heat engine with respect to temperatures T1 and T2 from the graph using adiabatic relations.
Expansion B to C. B coordinates are P2 V2 T1 and C coordinates are P3 V3 and T2. Then TV power gamma minus 1 equals to constant. From this T1 V2 power minus gamma power minus 1 equals to constant. T2 V3 power gamma minus 1 equals to constant. Then equate these two. Then T1 V2 power gamma minus 1 equals to T2 V3 power gamma minus 1. Then T1 by T2 equals to V3 by V2 whole power gamma minus 1. Let us consider this equation as A. And adiabatic compression is D to A. D coordinates the P4, P4, T2 and A coordinates the P1, P1, T1 from PV diagram. Then T2 V4 power gamma minus 1 equals to constant. T1 V1 power gamma minus 1 equals to constant. Then equalities 2. T2 V4 power gamma minus 1 equals to T1 V1 power gamma minus 1. Then here we write it as T1 by T2 like that. T1 by T2 equals to P4 by V1 whole power gamma minus 1. Consider this equation as B. Now equating equation A and B. Then V3 by V2 whole power gamma minus 1 equals to V4 by V1 whole power gamma minus 1. Then cancel this two. Then V3 by V2 equals to V4 by V1. Cross multiplication, exchange of V3 and V2. V3 by V4 equals to V2 by V1. Then now we have to find out the efficiency for this. Efficiency is denoted as eta, that equals to Q1 minus Q2 by Q1. Eta equals to, we had already known that Q1 value is RT1 log base C V2 by V1 and Q2 is RT2 log base C V3 by V4 by again Q1 value. Then eta equals to RT1 log base C V2 by V1 minus RT2 log base C V2 by V1 by RT1 log base C V2 by V1. Here we wrote V2 by V1 because we had already proved that V3 by V4 equals to V2 by V1. So we write V2 by V1 in the place of V3 by V4. That equals to R log base C V2 by V1 is common. Then here T1 minus T2 by same value. Then these two are cancelled. Then eta equals to T1 minus T2 by T1. Then eta equals to 1 minus T2 by T1.
Hence, the efficiency of heat engine depends only on temperatures T1 and T2, but it is independent of working substance. Impracticabilities of Carnot's heat engine. It is an ideal heat engine which is practically not possible to construct. In this heat engine, the heat energy absorbed or rejected strictly at constant temperature, which is practically very difficult. While we are observing the construction of working substance, source and sink, some parts are conducting and other parts are insulating, which is very difficult to construct. The heat engine has very slow working. It doesn't matter whatever be the efficiency of the engine. If it is slow working, it may be of no use in day-to-day life. Thank you.